guys, today we're going to be working on assignment number 8. We're going to be decomposing some baking soda with heat. Seems to be a theme of what we've been doing with our demonstrations. So if you ever wondered why we add baking soda to food, cooking, right? It's because when baking soda gets to a certain temperature, it starts to break down, which means that part of that is it releases carbon dioxide. Okay, so you can read the background here and read a little bit more in depth into that. But that carbon dioxide gas that it releases helps those baking products rise. Okay, like cookies, cakes, waffles, pancakes, etc. Okay? All right, so our objective today with the stoichiometry is that so there are 3 possible chemical reactions that could be occurring during the baking process. All 3 of these reactions shown below are theoretically possible, yet only one reaction actually occurs. So here are the 3 possible reactions. All starting with sodium bicarbonate, which is the chemical word for baking soda, breaks down, so one theoretical equation is it breaks down to sodium hydroxide plus carbon dioxide, or sodium oxide, carbon dioxide, and water, or sodium carbonate, carbon dioxide, and water. Notice that carbon dioxide is in all of these, and it is a gas, and water is in 2 of these, which is also a gas. Okay, so when we do our measuring, what we're starting with is this solid, and what we're going to end with in our test tube is one of these solids right here. Okay, this stuff right here, this is all getting released to the environment. So it's not going to be included in our mass. Not that it went away, it just got released to the environment. Okay, we didn't collect that. So conservation of mass still holds, but because these get released to the environment, this is what we're going to be measuring as our second mass. And what you're going to do is you're going to use stoichiometry to figure out which one of these is the correct one based on how much of this mass we should have gotten from our starting mass of sodium bicarbonate. Okay, and it's the same thing that we talked about in the previous assignments, the same equation. It's a mass-to-mass equation. Okay, all right, so before we do that though, part of this video I wanted to, so since these are in words, I wanted to walk you through how to write those out. Okay. All right, so the first one is sodium bicarbonate. So sodium bicarbonate is NaH. That's what the bi in there is referring to. CO3. Okay, sodium bicarbonate. That's going to break down into, and it's saying sodium hydroxide. So sodium hydroxide is NaOH, right? Because Na is a plus and OH is a minus, right? So ionically speaking, Na and OH go together. And then we're also saying for that first one that we are making CO2. Okay, and the reason why I'm doing this is because we're going to need the balanced equation to do our correct stoichiometry, right? Okay, so don't forget that this is a solid, this is a solid, and this is the gas. Okay, that's going to come into play later. All right, let's check for balance. 1 Na, 1 Na, 1 H, 1 H, 1 C, 1 C. I have 3 O's. So here's one right here, and here's the other 2. Okay, so on each side of the arrow, I have the same number of each element. So I don't need to add any coefficients to balance that equation. All right, let's do the second one. Sodium bicarbonate. Okay. All right, and then sodium oxide. So sodium oxide is Na2O, right? Because O is a -2, sodium's a plus, so we need 2 sodiums to balance it out. And in this particular case, we're saying that we're making CO2 and water vapor. Okay, so again, this is a solid. This is the solid. This is a gas. This is the gas. Okay, all right. So now let's check for balance here. So I have one Na, two Nas. Well, that's already out of balance. So I'm going to go ahead and put a 2 here. So 2 Nas. Now that makes that 2 H's. Got 2 H's over there. 2 carbons. Nope, don't have 2 carbons. So I'm going to have to put a 2 in here. Okay, now 2 times 3 is 6 O's. Let's check for O's. I got 1 here, 4, that's 5, and then here's number 6. Okay, so now that works out. So I had to put a 2 there and a 2 there for that balanced equation. All right, let's get this third one on here. Sodium bicarbonate. Into, and in this case, it's saying sodium carbonate. Okay, so that's Na2CO3, because carbonate's a -2 if you look at the charges, plus CO2 and water again. Okay, all right, and this is the solid. This is a solid. This is going to be a gas and a gas. All right, checking for balance. 2 NAs. Oh, got to put that 2 out here. Check that. All right, 2 H's. Got 2 H's. 2 C's. 1 C, 2 C. 6 O's again. 3, 5, and there's 6. So in this one, just needed a coefficient 2 out front. Okay? All right. You're going to need these after you collect your masses. Okay, because after you collect your masses, you want to find out for each one of these how much of these solids will be produced from this breaking down. Okay, and then whichever one matches up to our aftermass is going to be the correct equation. Okay, but you're going to need to work out possibly each one, right? So let's switch over to decomposing this baking soda and get measurements. All right, guys, so here we are, me and Cole in the garage, and we are going to measure out some sodium bicarbonate. Okay, so the first thing we're going to do is we're going to get our test tube. Here's your test tube, Cole. All right, and what should we do with the scale before you put your test tube on? And then what do you do with the scale?
Zero it.
We got to zero it out because we don't want the mass of the test tube, right?
Right.
All right, so go ahead and hit that 0 button. Okay. All right, grab your test tube. Careful with it. Okay. Now we are going to measure out some baking soda. Okay. So why don't you scoop a? No, you leave it, because when you put the test tube back on, it's going to take care of that. Okay. All right. So go ahead and get a scoop of sodium bicarbonate, otherwise known as baking soda. Okay. Remember I said go that way. There you go. All right. Now, why don't you pour it in off the workbench so we don't get the workbench all. There you go.
Yeah.
All right, no, that's good, man. All right, cool. All right, why don't you put it on there and see how much we got? We're looking for about 2 grams. Yes. 2.31 grams. All right, so here we got our 31 grams.
No, 3.2.
2.32 grams of sodium bicarbonate in our test tube, and we are going to heat it up. So Cole's going to light the Bunsen burner for us. Okay, so go ahead, turn the gas on a little bit.
Which way?
That way. Okay, you hear it. Keep going. I don't hear that. There you go. All right, now click. Click it on there. Boom. Good job. Alright. So we're going to slide that heat underneath our baking soda. We just want to kind of heat it up gradually. Anything interesting going on there, Cole? Watch your face in the fire. Yeah, it was kind of moving around. It seemed that all the gas that was releasing seemed to be jumping around. If you look at the top of the test tube, look at the very top of the test tube, we can see some steam and condensation collecting. Get our aftermass. So we have an aftermass reading of 1.36.